I left her partway through her degree and took a job at a neighboring state to the east. But today, enough about that. Today is Channing's day. She is here to defend her master's thesis with said title. Give a little bit of background. Channing did her undergraduate degree at Purdue University. She's from Indiana. And then she went into the professional field. She worked a lot for USDA APHIS, both in Indiana, moved her out west to Montana eventually, worked here in Utah, did some work with U.S. Fish and Wildlife, and then landed a job with Utah Division of Wildlife Resources. And while on the job, it was this kind of idea for a project of evaluating the efficacy of how, as Channing will talk about, kind of urban and suburban mule deer of a potential management tool to move them out of the city, more or less, to see what happens to them. Is it effective from both a sociological as well as a demographic angle? So she's been doing this while on the job with Utah Division of Wildlife Resources. So it's a bit somewhat different than most of our students because she's been in her career and just maintained her career while coming back to get her master's degree. And she'll tell us about that project today. Take it away.
Awesome. I really appreciate you guys all being here today. This means a lot to me to see a full crowd. So I'm just going to jump right in and start telling about our research project. So human populations had increased exponentially across the globe. And in doing so, we have altered environment, including habitat changes, fragmentation, and creating development in urban and suburban areas. Wildlife and humans have increasingly come into contact in these developed landscapes. And when they come into contact and have interactions, sometimes they can have a negative effect. And this leads to human-wildlife conflicts. As these landscapes have changed, it has negatively affected some wildlife species. However, others have developed some sort of characteristics that have helped them adapt and even thrive in urban and suburban environments. As wildlife adapts to these urban environments and come into close contact with people, the potential for human-wildlife conflicts increases. For example, Canada geese have become overabundant and could cause damage to parks, eating grass in the landscaping. And they also tend to become very aggressive, knocking over a high school golf team. Also, black bears have learned to use human-sourced food by raiding trash bins. And also, apparently, they've also had swim lessons in backyard pools. When these interactions have a negative effect, they cause damage, become dangerous, management and interventions must be employed. Traditional human-wildlife conflicts, management interventions have revolved around lethal management of the individual or the problem species. Demonstrated here by idling eggs for the geese. This helps reduce the number of goslings that are produced each year, as well as actually rounding up adult geese and removing an entire population. And for black bears, lethal management has involved the actual killing of individual animals that are causing problems. Don't worry, he was okay. They caught him. However, non-lethal management techniques have become a regular part of human-wildlife conflict management and mitigation. Some of these techniques involve education. I really like this sign because this really describes perfectly the education component. Tell them why we shouldn't feed birds, and then they give alternatives as to what birds might actually like and what might be good for them and good for the environment. Seeds, grapes, apparently cooked rice, bird seed. In the case of black bears, implementing bear-proof trash bins and teaching people how to use them properly has been instrumental in a lot of areas that have bear problems in the garbage bins. And then one other way that they can solve problems that occurs with bears frequently is actually the capture and translocation of individual problem bears. However, one particularly challenging human-wildlife conflict is that with overabundant deer. Overabundant deer can cause a wide variety of problems, including damage to agricultural fields, landscaping. They can overbrowse forest ecosystems so that the undergrowth isn't even able to come back, preventing regrowth of the understory vegetation. And in the eastern US, Lyme disease is a big issue for overabundant deer. And then, of course, safety on the roads. I mean, who out of us doesn't know somebody who's hit a deer at one point? So regulated hunting is the primary way that wildlife agencies manage deer populations. And extra steps must be taken when deer become overabundant. So some ways that can be accomplished is by controlled hunts. Controlled hunts are really useful in areas such as state parks, where regular hunting is not allowed, and there are areas where they can close them off and only allow in the hunters to restrict access to the public during these controlled hunts. Archery hunts are another useful method in small areas. Archery hunts, the costs are usually minimal because the archers themselves pay for a tag, and they're not paid for their efforts as it is a hunting opportunity for them. But because success rates of archers is low, these methods are generally not as effective as a standalone method. For sharpshooting over bait, that's actually pretty common in some areas now. It didn't used to be as common, but it's also proven to be fairly effective at reducing deer populations. And reported costs for this are reasonable. However, all of these methods can be prohibited in high-density urban areas. And the perception is often that these methods are unsafe, and therefore the public does not support them. For non-lethal deer management, there's a lot of techniques that are out there. Education is a big component. That is something that you can use in conjunction with any other management technique. Deer-proof fencing is a really effective way to keep deer out of a yard, to keep it out of an area where you want to have trees or plants. However, if a large area needs to be fenced, it can be quickly become very expensive. Immunocontraceptives are another method that are being tested out, and generally it's only available for white-tailed deer, and it requires 1 injectable dose per year to prevent pregnancy within the doe. This method is most useful in closed populations, such as on island or in a fenced area, and it's not generally a good method if you're looking to control the population immediately, because this will take a couple years to take effect at reducing the population. And of course, translocation. This method is generally seen by the public as more humane and can have high public support compared with lethal methods. There are 3 species of deer which range across North America. White-tailed deer are generally throughout most of the area except for basically where we are. They go Canada down to Mexico, and then mule and back-tailed deer are mostly in the western US. And as somebody pointed out to me, apparently there are no deer in Central California. So lucky them. For the rest of the talk, I'm going to focus exclusively on mule deer. So mule deer have experienced some historical range-wide declines. And this can be a factor due to one or more factors. Habitat degradation or changes, encroachment of pinyon juniper, oil and gas development, and urban development in the wintering areas, as well as predation and winter kill, especially after harder winters. In Utah, there was a historical decline since the 50s of mule deer harvest. So these aren't actually numbers, these are actually harvest numbers. And you can see here, starting about 1992, the Utah Division of Wildlife began estimating deer populations. There was a heavy winter. The population took a nosedive at that point and has remained relatively stable since, with a relatively stable number of tags of deer harvested each year since then. There's been extensive efforts to actually increase mule deer and improve their habitat throughout the state. The UDWR and partners have restored more than 1 million acres of mule deer rangeland across the state. And in 2012, the Mule Deer Protection Act was passed by the Utah State Legislature in an effort to boost fawn survival. And many of you may be familiar with this. This is known as the Coyote Bounty Program. In recent years, some areas of the state have seen a recent increase in mule deer populations. And this little purple pink area is the East Canyon Wildlife Management Unit. And this unit in particular has seen a population double from 2008 to 2014. Throughout Utah, human population densities are very urbanized. 75% of our population here in the state, of the 3 million people that live here, live in the Wasatch Front. And between 2015 and 2016, Utah was the fastest growing state in the nation, growing by 2% in just 1 year. And our populations are expected to increase to 5 million people by 2050. And when over-abundant deer live in and around our urban areas, they can become a nuisance, create conflict, and get themselves in pretty precarious situations. Many of these are very familiar sights to those who actually work with deer on a regular basis. The Utah DWR has experienced increased complaints and costs due to these increases in complaints about nuisance deer. This is just the amount of time and effort it has been taken for staff to respond to nuisance deer calls. And this is usually in the form of roadkill, dead deer in somebody's backyard, dead or almost dead deer on a fence. But a large portion of time has been spent on that, and it's been creeping up and increasing. And this increase in calls has led to an increase in cost and time to respond, and a need to develop a plan to address urban deer issues. In 2010, the Utah Division of Wildlife worked with the city of Bountiful and went in to do some sharpshooting to remove some urban deer. However, after only 2 days of the sharpshooting program, there was a lot of opposition. So the program was halted. And at a city council meeting a few months later, there was a moderate-sized protest. And there was a lot of public outcry. So people were pretty upset over seeing the deer get killed and really wanted another option. So this is when the Division of Wildlife started looking at translocation. So translocation is traditionally used to do 3 main things with wildlife: to bolster declining populations. It's used a lot with bighorn sheep. Over on the right-hand side, they're translocating some bighorn sheep. It's used to reintroduce extirpated species, such as the wolves in Yellowstone National Park. And of course, to reduce overabundant species. Since the early 90s, mule deer populations in Utah have been generally stable with some moderate fluctuations. However, mule deer population, the solid line, is still well below the population objective. So we've got a little bit of room there that indicates that translocation could be a potential tool to use in Utah. However, there's some barriers to translocation. In general, translocation is seen to have low survival. So to give you an idea of what annual survival rate for an adult female mule deer is in the Intermountain West, it's about 83%. In comparison, for a translocated mule deer, one study found a 15% survival rate for California black-tailed deer, and New Mexico deer survived at about 49% over the course of a year. And high cost. This is generally seen to be a costly method. There's a lot of hands-on, a lot of things involved with this process. And previous research has reported costs from anywhere from $113 to $570. Now, when you translate some of those numbers into actually current day dollars, that range is about $500 to $1,300 per deer. And a lack of appropriate release sites is another issue for translocation projects. This is generally a barrier to any white-tailed deer programs. There just aren't any areas where the road density is low enough that they don't get hit by cars. and they're too near human activity. So they go to another urban area, they go to somebody else's backyard and cause more problems. So our overarching question here, does translocating urban mule deer work in Utah? So to find that out, we're going 2 routes. In chapter 1, I'm going to estimate the survival rate, and the annual survival rate, and look at factors contributing to the survival of deer. Then we're going to calculate the cost per deer and identify each stakeholder's contributions. In the second chapter, I evaluate the change in attitudes towards deer management actions, and the change in perception of the severity of problems that deer cause. And our second objective in chapter 2 is to identify the factors that are influencing these residents' attitudes. So chapter 1, our capture site is Bountiful, Utah. It's northern suburb of Salt Lake City. It's nestled up against the foothills of the Wasatch Mountains, and has a history of mule deer conflicts. For our release sites, we had a number of criteria that were important that each of these locations fit into. Population had to be below objective for greater than 5 years. There had to be adequate underutilized winter range. There needed to be public land open to hunting. We wanted to take these deer to an area where they were available to hunters. And then they had to be far enough from the capture site so we didn't have the deer either returning to the capture site or being near agricultural fields and causing a damage for our farmers and ranchers. And lastly, it had to be a chronic waste and disease-free site. We don't want to be spreading diseases around the state. So the release sites that we chose for this research project are the Raft River Mountains in northwestern Box Elder County, and Big Wash, that's in the Uinta Basin in Duchesne County. And both of these areas were about 130 kilometers away from Bountiful. So we supposed that the deer would not make it back. That was the goal. For our data collection, we captured deer in the winter of 2014 and 15, and then again in 15-16. We used clover traps and drop nets. We used clover traps both years and drop nets the first year in conjunction with the clover traps. We captured all ages and sexes. We radio collared the adult females, and the adult males got the ear tag transmitters. And both of these telemetry devices were equipped with an 8-hour mortality sensor. We also recorded age based on tooth wear, body condition based on a good, fair, poor rating. And then we recorded any injuries that were sustained prior to or during capture. Urban deer seem to have a lot of bumps and bruises and that sort of thing that were prior to capture. So we started collecting that data early on. Then the deer would be loaded up into a trailer and taken to one of the 2 release sites on the same day and released. And then each capture day we would alternate between release sites to try and even out the number of deer going to each release site. So total numbers, we caught 99 collared deer the first year, and the second year we caught 117, for a total of 216 collared animals in our study. For our data collection, we did monthly telemetry flights at each one of our release sites. And recorded fates as alive, dead, or not heard. So the deer that were released in 2014 and 15, we monitored them for 2 years. And the deer that were captured in 2015-16, we monitored for 1 year post-release. Then for our cost, we gathered our costs from personnel time, equipment costs, mileage, and monitoring effort. For data analysis, we used Anderson-Gill formulation of the Cox proportional hazard. This allowed us to estimate the covariance effects on a hazard of dying. So what is the risk of dying based on this variable? And it also allowed us to have, to censor, and I'll explain what that is in just a minute, and have ragged monitoring intervals. Some months we weren't able to fly, and so your telemetry intervals aren't exactly perfect. And this allowed us to use our rough data, and it worked really well. And it also allowed for stratification of variables when they're not proportional. So basically what this looks like, we have 4 example female deer and then months of monitoring. So female number 1 entered the study at the very beginning of the study, and she was monitored as alive until the end of month 3 where she was marked as dead. And so she completed the study. We marked our time interval, our time of death within the study time frame. For female number 2, she entered the study a month in. As we were capturing, we had a lot of this because we captured multiple times a week, and so every animal entered the study continuously. And this is called a staggered entry. Female number 3 entered the study at the beginning, and then at the end of month 2 was not heard again. So we'd fly, wouldn't hear it. So we couldn't say if the deer itself was actually alive or dead. So the animal is not heard, and therefore we right censored. And female number 4 was right censored. We didn't hear it for month 2 or 3, but then again we picked her up again as alive, and she re-entered the study. So she was right censored, and then re-entered the study as alive and continued on. We did a tiered model selection using our capture and handling covariates, taking one of our top model from there, bringing it forward into our next tier, adding in our individual characteristics, running interactive, univariate, interactive, and additive models, and bringing those forward into our top tier, where we actually brought in the last remaining tier variables, such as the cohort variables. So our top model ended up being year post-release plus an interactive effect of age times injury. And we stratified sex because it was not proportional, so sex was stratified throughout our model. So what that looks like on a hazard ratio scale is here. So we are estimating the hazards. So for every year post-release that increases, it reduces the hazard, which then has a positive effect on survival. Alternatively, the interactive effect of age of injury has, as age increases and you go from a no injury category to an injury category, there's an increased risk. And your increased risk leads to a negative effect on survival. So what does that look like? For annual survival for our translocated female mule deer, we have the survival probability here. We have our no injury category here. These deer are the first year after release, and these deer are in their second year after release. So overall, we saw that younger deer fared better than older deer. We've got the young, average, and older category. And then those deer that made it past their first year after release and survived into the beginning of their second year had a higher survival rate. But we still saw that as those deer also increased in age, their survival decreased. So now we're going to go over to our injury category. And in this category, we saw the same thing with increased age, survival decreased. However, the effects of injury were minimal for younger deer in their first and second year after release, but it increased with age. So now we're going to look at male survival. So same type of chart, just male survival. First year after release, we had lower survival overall than female, but the younger males also survived better than the average or older age classes. And then those that made it into the second year post-release, this average age deer were the only ones that made it into the second year. They had a higher survival in their second year. When we look at the injury category, again, the young deer survived about the same as those that were in the no injury category. However, the effects of injury increased as the age increased. And we had no deer in the injury category that made it into their second year post-release. No males. So for total cost for our project were just over, for this research, was just over $400,000 for the translocation monitoring project. So that came out to be just over $1,000 per deer captured. And when you break down by stakeholders, UDWR managed 80% of that. And to put that in dollar terms, that's approximately $800 per deer that the division paid for. So in summary, overall, our annual survival for our translocated deer are lower than average annual survival for deer in the Intermountain West. However, our survival for our adult females is similar to other translocation projects in Utah and New Mexico. However, our survival for males was much lower. There is some evidence that male survival in the wild is lower than females due to hunting. We had 5 of our males that were reported as illegally harvested during our study, so that doesn't quite account for all of this variation. But there's really no other, there's really little research out there on translocated adult males to compare with. With the cost, overall the costs are closer to the upper end of the range of reported costs for other projects, and it is more costly than lethal. However, costs were defrayed across multiple stakeholders, which just defrayed. Chapter 2 is attitudes, perceptions towards urban mule deer in Utah. So our objectives for this, again, were to evaluate attitudes towards deer and deer management, evaluate change in attitudes, and then identify factors influencing these attitudes. For our survey instrument, we used a telephone survey. We were able to get Bountiful Utility customers' phone numbers and addresses from the city, and that really helped us because it allowed us to make sure we were reaching both landlines and cell phone numbers. We asked a couple of demographic questions, looking at, are you a homeowner or renter, your length of residency in Bountiful, and then we really wanted to know, out of our sample, how many people were aware that this trap and relocation was about to begin. So our survey instrument was a Likert-style survey question. There were 10 questions total. We asked about 3 different attitudes towards deer and 3 different attitudes towards management actions. And these management actions that we asked about were actually pre-approved management actions that the division could implement within the city. So the first one was trap and relocation, and then using trained and certified archers, and then trap, euthanize, and donate the meat. These all 6 of these questions were on a Likert scale, 1 strongly disagree to 5 strongly agree. And with our perception of the problems, we asked 4 different questions, and I'll get to those in just a second. Those were on a 4-point Likert scale, 1 no problem, 4 to serious problem. And then in 2016, we added 1 more question. We wanted to find out what time of year residents were actually having a problem with deer. Was this a year-round problem? Is it seasonal? What's going on there? So the 4 problems that we asked about were really based on types of problems that were most commonly asked about. So of course, roadkill, it's a big concern. Damage to gardens and landscaping. Confrontations with pets or people. And of course, general mess left in the yard, which basically means poop. I hear a lot of complaints about poop. So we asked about that because that is a legit concern. Kind of giving you an idea of when all this happened, I made a little timeline. So our first survey was administered in late 2014. We asked 488 people. We got 488 responses. And then shortly after that, we began our first deer capture season, and that ran from December of 2014 to March of 2015. And then the following year, in December of 2015, we started up with the second trapping season that went until February 2016. And then 2 years after the first survey, the same month in 2016, we administered our post-survey. So the first number, the 247, we were able to reach 247 of these respondents, these first respondents. And so that sample became our longitudinal survey. We've got their answers from 2014 and 2016. Then we asked a handful of new residents. So we've got new respondents in the 464. And that group as well as the whole 488 became our cross-sectional survey group. So for our data analysis, we used this longitudinal panel of the 247 respondents, and we conducted a paired t-test to see the differences between 2014 and 2016. We used all 10 of our questions and included the awareness of trap and relocation. Our cross-sectional group was used for reporting frequencies for 2014, so our baseline frequencies. And then we used a multinomial logistic regression to really get at what factors are influencing their attitudes towards deer and deer management actions. So our sample size for the multinomial logistic regression was about 945, and we used the backward stepwise regression or model selection using BIC. So the results, these are just the frequencies of our 3 attitudes towards deer. There are too many deer and bountiful. Something should be done to reduce numbers, and deer are native and we should learn to live with them. A majority of respondents agreed or strongly agreed that there were too many deer and bountiful, and that something should be done to reduce the numbers of deer and bountiful. However, an even greater number of people believe that deer are native and we should also learn to live with them. I'm guessing people could hold multiple different attitudes at the same time. So these are 3 management actions that we asked about. And as you can see, trap and relocation was supported more than using trained and certified archers or trap, euthanize, and donate the meat. Of our perception problems, we found that damage to gardens and landscaping, more than 50% of respondents felt that that was a moderate or serious problem for them. Second to that was vehicle collisions, and then general mess left in the yard, and then confrontations was the problem of least concern to the respondents. So this is our 2016 new question. So this is only our 2016 respondents, and they felt that winter was actually the season with the most problems, deer problems in Bountiful. So for the results of our paired t-test, we've got our effect size on here, and I'll go through our 10 questions and highlight the ones that were most important. So awareness of trap and relocation program ended up being the most interesting. Awareness of the program increased over the course of the project. And then within our attitude questions, the attitude that there are too many deer in Bountiful actually decreased and became more neutral. Among the questions about our management actions, support for trap and relocation increased. However, there was no change in support for either lethal method. Similarly, there is no change in any of our damage questions. There is no change, positive or negative, in either one of those, any of those. So I'm going to walk you through some of our multinomial logistic regressions. These are our predictor variables that came out in the model, and this is the question that they are predicting. This is our beta here, and basically 0 is neutral, and then as you go this way, the respondent is more likely to agree. So what it looks like is this. And if you look here, you see that those who responded that damage to gardens and landscaping were severe were more likely to agree that there's too many deer in Bountiful. Along with that, those who said that a general mess in the yard, or poop in the yard, that was a moderate or severe problem, they were also more likely to say there's too many deer in Bountiful. When we asked about should we reduce numbers within the city, we saw very similar. Damage to gardens and landscaping was the best predictor for reducing deer numbers. And then our last attitude question, should learn to live with deer. So this is opposite. So we're going negative, so it's less likely to agree. With this, we also found out that those that are experiencing severe damage are less likely to believe that they should learn to live with deer. Of our management actions, trap and relocation was the only one that that really didn't have damage to gardens and landscaping come out as significant. But aware of trap and relocation program was the most significant with this. So those who were aware that the program was occurring were more likely to agree that that's an appropriate method to use. Of the two lethal management questions we asked about, trap, euthanize, and donate the meat, damage to gardens and landscaping was the only predictor variable that came out. And of course, once again, those who are experiencing severe damage were more likely to agree with that method. And very similar with the trap, with the archery, those who are experiencing severe damage were more likely to agree with that method. So to summarize our second chapter, in 2016, fewer residents perceived that there were too many deer. However, that remained above the neutral midpoint. On Hilton Head Island in South Carolina, permanent residents were actually able to accurately perceive a 50% reduction. It was an experimental reduction. They were actually able to perceive this 50% reduction in an urban deer herd. And while we removed 465 deer over the 2 years of trapping, we don't know the actual deer density in Bountiful. So it's possible that residents could just be perceiving a decrease in deer over there actually being a decrease in the number of deer within the city. Also, the severity of our problems did not change over the 2 years. People reported the same level of severity across all 4 different types of problems. And this lack of change could indicate that while enough deer were removed, that the remaining deer were still able to damage gardens and landscaping and create deer vehicle collisions and poop on Mr. Christensen's lawn. Alternatively, it could mean that we just need another growing season or 2 for people to see their gardens and landscaping recover from deer browse. So we also discovered that winter was the season with the most problems as reported by our respondents. And this could be due to the mule deer's tendency to form larger herds in the winter. And also after the leaves fall and there's snow cover, it's a lot easier to see these herds in your yard, even if you're not out in there. And then once the snow's on the ground, it's very easy to see foot tracks, prints, droppings, and see, oh yeah, there were deer in my yard last night. And while gardens are finished for the season, regular landscaping is still available to deer. So residents can still experience damage to gardens and landscaping in the winter. So we also found that our attitudes towards deer were very similar to attitudes towards deer in whitetail deer studies. That negative attitudes and people who are experiencing damage are more likely to have negative attitudes and are more likely to support lethal control methods. So in conclusion, we found that injuries sustained prior to and during capture have a negative effect on survival. So one potential way to prevent that, at least the capture-related injuries, is to modify traps or the trapping method, capture and handling methods to try and prevent those injuries in the first place. We also found that younger deer may actually fare better and their survival may be higher than older deer. One of the positives of this is that we actually found out that some of these deer were actually available to hunters after they were moved out there. And translocation was costly compared with other methods. However, it has higher support than the lethal methods. So our social surveys highlighted the attitudes towards deer and the factors that influence the attitudes. But because our effect size was small, it may be beneficial to continue removals past 2 years. And that way, the benefits of a reduced population may be felt by the residents in the city. And lastly, one of the benefits it may be beneficial to actually estimate the deer abundance within the city. That way we can actually see the difference between actual abundance and perceived abundance and decouple those two factors. So my hope is that managers are able to use this information to evaluate cost, public perceptions, and survival when looking at translocation as a long-term management tool. And with that, I'd like to thank my advisor, Dave Coombs, my committee members, the Division of Wildlife, Scott McFarland, Rod Nielsen, and Brian Christensen, my funders and volunteers, the City of Bountiful, the employees of Bountiful, and all the residents that let us in their backyards, and the more than 80 volunteers that helped us in the field with this project. I couldn't have done it without this group. They were instrumental. So with that, thank you for having me. I really appreciate it.
So I have 2 questions on survival. What was the overall survival? Maybe I missed it. Like in general.
How about for adult females?
Okay.
For adult females,
Yeah, okay,
it was roughly around 50%.
Okay. And then on your graphs, your bar graphs,
Yeah.
your error bars looked quite large.
They
Is
are.
there a yeah, I get that. That's fine. I mean, it's
Yeah.
wildlife, right? Is there a significant difference in those or not? Are they significantly different than each other?
I don't know that, but I know our sample size sometimes is smaller for some of those groups, the way they're broken out.
Mhm.
So I know that can have a big effect on those error bars.
I was curious the spatial distribution of your trap sites in Bountiful. I mean, is it 3 or 4 places, is it 20 backyards? How distributed was your effort? And then are you just sucking them in from the
So we sort of broke Bountiful up into sort of this 4 different elevational gradients and sort of these bands that go across, because the city is really on an elevational grade. And we really had to pick properties where people wanted us to trap and that were feasible to get to, that could, get access in. But in general, we had traps. Bountiful situated north-south, and it's a gradient east-west. So we had traps strung out north to south, and it was really focused in the middle parts of the city. So we didn't trap above Bountiful Boulevard in the mountains. It was further down in the city. We had anywhere between 6 and 12 trap sites going at one time across the city during both seasons. Mm-hmm. And we'd move them around too. So they wouldn't stay necessarily in the same place the whole season.
Well, I was wondering, did you find that if you trapped one spot, the deer weren't there, so you moved the trap?
Yeah.
I mean,
So
you
we
solved local problems.
Yeah, because the people that signed up for the program through the city, they were one that had deer in the backyard and they wanted the deer gone. So we were able to kind of find where these deer were based on those residents. And then, there were some places that I wanted to use, but they didn't have deer in their backyard during our trap season. So we moved the trap to another location.
Were they part of your sample of public attitudes?
Our public attitudes included a lot of people across the entire city. It was homeowners, renters, people living in every area across the city. There were some people that were part of the program that ended up being in the survey.
Okay.
Mhm.
Curious what their attitudes were.
Yeah. I think they're pretty happy, actually. Yeah. You want to go to these?
So, the harvest data.
Yes.
So these deer that are used to being in cities are used to being close to people, and then they have moved out. So, did you notice the ratio of animals that were translocated and then harvested versus other animals harvested from that area? Is there any data to suggest that they're more or less likely to get hunted than other deer?
That's a good question. There's probably a way to get at that, but I don't know it off the top of my head. There's probably a way to get that. I couldn't tell you off the top of my head. Yeah.
How many total for sure?
Within our study time frame, out of the colored deer only, we had 5. There were 2 more that harvested. One was a female who had wandered into an area where she was legally harvested, and then another male was his transmitter failed, so he didn't even enter the study, and but he was harvested, and so that's how I know what happened to him. So really there were 7 deer total that got harvested, 5 that were part of the study.
So I have a really geeky question. On the second chapter, you did a backwards
Stepwise
Yeah.
model
Why
selection.
did you do backwards stepwise as opposed to, small go up?
It was the type of model selection that the regression we were doing was just, it was big and cumbersome, and we only had 9 variables, but some of those variables had, like the damage to gardens and landscaping had 3 different levels. So it was a lot easier because we had 9 variables to just load them in and then pick out which ones didn't work.
And you had enough data. You had 946 or
Mhm.
something like that to run. So a single data record for each of the 946.
Yeah, each one of those was a unique individual.
So with the cost estimate, where did most of that cost come in? Was it trapping, translocating, monitoring?
A largest portion of that cost is really from labor. The division had to hire 2 full-time employees to do this program, and out of all the different ways to break down the costs, that was really the best way to do it because there was actually more than 2 employees that were there during each capture day, and that didn't even account for Scott's time that he put in on the project to get it going and to help out and all that kind of stuff. And of course, the 2 technicians were not paid very much money, so that kind of saved some costs there. But that's how we broke down for labor from the division side. I really went simple with the cost here because there's a lot of different ways to break it down. So if you would like some more information, I highly recommend you pick up my thesis when it gets colder. Michael?
Channing, related to cost, I know I've seen in the newspaper that there's other towns now that they know this comes from, about implementing this. So you say $1,000 a year, that's gonna get really expensive for when you start adding towns to that. What do you think the long-term future of this as a management tool for the division is if other towns are really starting to worry about their deer population?
Currently, we have at least 3 or 4 cities on board that are actively doing some trap and relocation methods. So it definitely keeps us busy. But as far as the cost, if a city has the funds and can pay the cost that the division lays out as a per deer cost to the city, and we have the manpower to do it, we'll do it up to a certain point based on the manpower that we have, and we'll prioritize the cities. So this city signed up first, or the city has a bigger problem, or and be able to handle multiple cities in that way. Does that answer your question? Yes.
So it's curious, if you're moving that many deer from the urban environment, those likely probably in the summer return to the high country. Is that an assumption?
I think that's an assumption. I've worked with a lot of the homeowners for multiple years now, and they have fawns in the backyard every year. So there are definitely deer that are there all year round in the city, even further down in elevation in the city.
So I'm just curious, is this a year-round resident population in Bountiful, or is it just migration?
You know, we don't have any like GPS collar data or anything to support that. I wish I did, because that's really that's important information to know. I want to know, you know, what kind of impact am I making by taking out these deer? Where are they going? What's what's the population size in the city? So that's actually something I would love to do to find out what's actually going on at that level within the city.
I'm just curious about hunters feeling that opportunity is being taken away from them in the fall because you're.
Well, these deer are actually in the city.
winter.
These deer are in the city in the fall.
Yeah.
So there's a lot of deer. I've had a lot of trail cameras up, and it seems like before the muzzleloader season, the deer are in the city, or at least whatever deer we catch are there. So there's definitely a lot of deer that spend a lot of time in the city.
Gut feeling, how tricky do you think it would be to catch deer in July?
I actually have some coworkers that are trying it, and they say carrots are working. Yeah, it's going to be really, really hot though in July. It's going to be really stressful on a deer. I mean, they already stress out and their body temperature rises in the winter, so I can imagine trying to catch them in our 100-degree heat. But I've heard carrots might work, so I'll have to try it out.
It's that or sticks.
Yeah, a little bit of both, a stick and a carrot. No. Any other questions? Cool.
So you didn't have any way to measure capture-related mortalities with just using VHF?
Nope.
Transmitters, right? Because you got an associated amount of time in this trap, the one-on-one wrestling match, and then the 130 kilometers in a horse trailer.
Yep.
To then measure like the 7 days out.
Yeah.
You know,
We have no idea. We have no idea. That's one of the pitfalls of doing the VHF and doing monthly telemetry flights and putting deer out every other day at 2 different release sites that are a 6-hour drive apart. And I know you're good with logistics, but could have used you back then.
How many or what % just dropped off the air, disappeared out of your known fate?
Like from the get-go that we never heard, or just in general?
After they've been out for a while, so I'm thinking of, did they move out of the area you put them in so far that you could detect?
Yeah, so based on our telemetry flights and where we were picking them up, some of the deer went more than 40 miles. So it ended up being very difficult to try and find where all these deer went. And of course, seasonally, they were in different places. So that part was definitely difficult. But there were some deer that dropped off. But we actually looked at ear tag transmitters versus the collars, and there was no difference in detection. So I don't think any of that had anything to do with, not being able to detect an ear tag transmitter. It was, I think, more of a function of where the deer went and just having absolutely no clue where they went and just having to guess at well, this area looks green, let's go fly over here.
Would you recommend using some percentage of GPS radios?
Yeah, I would. We looked at doing that, but it just wasn't feasible at the time and that sort of thing. But of course, 3 years later, 4 years later, I definitely recommend doing some of those because we just don't know where these deer are going or what they're doing, what their patterns are. And that would actually tie in nicely with some of the wild deer that are now collared around the state. You could see what does the translocated urban deer do compared to, wild deer over here. Yeah.
So this has been a few years after your scope of your project. How many deer today can you take out of that? Do you see any change in attitudes or perception of the deer now compared to 4 years ago?
We've taken out 689 deer to date in Bountiful. And I've made a lot of friends in Bountiful. The residents are so sweet and so kind. And they love having us out to catch the deer in their backyard. They really enjoy this program. And I definitely think that perception, I notice people's attitudes change. When you go talk to them and they're really frustrated over this deer and, telling you about this buck that was, this big and this high in his backyard and he's scared for his children and showing you all the damage on his trees, and you go talk to him and you put a trap in his backyard and you catch that buck, he's happy. He's really happy. So, I mean, this definitely has an impact on the residents that we work with one-on-one. Anything else?